So hello everyone. Today we start with this question. And this question was came in IIT JAM 2025. In this question, the question asked about major products P and Q of the following transformations are. So first we check this reaction number 1. We saw they are giving one molecule and they give base to react. In this molecule on C1 and C2 carbon they give two substituents like bromine and carboxylic acid, and on fourth position they give one isopropyl group. So first we label these carbon atoms, so it will help to decode stoichiochemistry of this molecule. C1, C2, C3, C4, C5 and C6. If we saw this kind of compound who have 1-2 position, one leaving group is present, so this kind of compounds give elimination reaction. In elimination reaction we all know, in elimination reaction one sigma bond convert into a double bond. So here this bond C1 and C2 bond convert into double bond, so they are giving base. This kind of reaction show E2 elimination reaction. In E2 elimination reaction always anti-periplanar hydrogen eliminate. So in E2 elimination always anti-periplanar hydrogen atom remove. So in cyclic compounds, how we check anti-periplanar? First, when they give this kind of compounds, first we convert this compound into a chair form. So in chair form, this position, axial position, and this axial position, C1 and C2. C1 and C2 carbon, they both have axial position in anti-periplanar. So if C1 atom have leaving group, in this kind of reaction always stereochemistry is very important. So whenever you saw this kind of question, you always remember stereochemistry in your mind, and first you convert this kind of compound into a chair form. First we convert into a chair form. Now we draw all giving substituents in this chair form. On C1 carbon we mention this carbon into a C1. This is C2, C3, C4, C5 and C6. So on C1 carbon they are giving one bromine atom. We all know in chair form all upward axial positions are wedge positions. All axial are wedge positions, and down axial positions are representing by dash. So we always keep in mind all upward axial positions are mentioned by wedge, and downward axial position always represent by dash. So on C1 carbon they give one bromine atom at wedge position. It means axial position. So we draw bromine. On C2 carbon they give carboxylic acid on wedge position. We know here dash, so at equatorial position wedge. So here we draw wedge position on C2 carbon here, and axial position we draw one hydrogen atom. So this fourth position they are giving one isopropyl group. And we always remember one thing, whenever you saw isopropyl group always exists at equatorial position, and this chair form don't flip because of isopropyl group is very bulky at equatorial position, so this chair form not convert and present at equatorial position. It is a very bulky group, so this ring not flip. So in the presence of base, this hydrogen atom remove by this base, so S2O will remove, and this carbon hydrogen bond electron shift to number carbon atom number 2. So this bond electron shift to here. We draw other same here, bromine at dash position, hydrogen here also equatorial position, one hydrogen. So this electron goes to here, and bromine leave this group as a leaving group. So here one double bond form, hydrogen comes in plane, and here CO2H also come in plane, and isopropyl group same as equatorial position. So this is our final product. We convert our final product into this form. So here first we mention C1, C2, C3, C4, C5 and C6. On C1, C2, one double bond came. On C1 carbon, one hydrogen present, and C2 position carboxylic acid, and C4 position isopropyl group same. So this is our product P. We check our answer will be C or D. So we check second reaction. In second reaction, they give bromine and CO2H at transposition. We all know that when C1, C2, when they are giving C1, C2 substituent axial and equatorial side, so we called cis. And when C1, C2 substituent present on C1, C2, they are on axial, we called trans in chair form. So here first we convert this molecule into chair form. Because bromine and carboxylic acid, they are trans to each other. So first we draw chair form of this compound, and we all know all axial position, upward axial position represent by wedge. So here bromine came, and carboxylic acid at trans position. So this axial position carboxylic acid came. Here one hydrogen, here equatorial position one hydrogen, and fourth position one isopropyl group present same like C1, same like reaction 1. So here we saw in reaction 1 and reaction 2 only difference is cis and trans. Bromine and carboxylic acid in reaction 1 they are giving cis position, cis isomer, and 1,2 position in reaction number 2 bromine and carboxylic acid trans to each other in this reaction. So if we mention in chair form trans, so first we draw bromine and carboxylic acid trans to each other. Here cis. So we solve this reaction. Presence of base here strong base is present. So here we saw at 1 2 carbon number 2 no alpha beta hydrogen is present, because in elimination reaction always beta hydrogen will remove, but here it is not possible. At here beta position carboxylic acid present, and we can't flip this ring also because on fourth position isopropyl group is present. So so we remove one hydrogen from this carboxylic acid. If we open this structure, here Br, here equatorial position hydrogen, here also wedge position one hydrogen is present. So in this condition, this electron goes here and this carbon carbon bond electron shift here. So here so these electrons shift to here between C1 and C2 carbon, and this leaving group leave this carbon atom. So between C1 and C2 one double bond is formed. This hydrogen atom comes in plane, and this hydrogen also came in plane. And here isopropyl group same, here also, here also. So we convert this chair form to this form. On C1 C2 carbon one double bond, this is our C1 C2 carbon, so one double bond present. On C1 C2 one hydrogen present, one hydrogen present, and fourth position isopropyl group present. So this is the final product of our this reaction. So this is the product Q. So we check our product in giving options. We saw these options, product P match with C and D, but our product Q only match with option number D. So the correct option is number D. So our correct option is D.